Have you ever wondered how your phone just knows where the faces are in a photo? Or how a self-driving car can spot a stop sign? It really does feel like magic. But today, we're going to pull back the curtain and see exactly how an AI learns to see the world around it. When you look at a picture of a cat, your brain instantly gets it. You see the pointy ears, the whiskers, the whole fluffy package, all in a split second. But a computer? A computer sees something completely, and I mean completely different. And what it sees is the secret to pretty much all modern computer vision. Believe it or not, to a machine, this cute cat photo is nothing more than a giant spreadsheet. That's it. Every single color, every shadow, every little detail is just translated into a massive grid of numbers. The computer doesn't see a cat, it sees pure, raw data. Just look at this. Each one of these numbers here represents a single pixel. One tiny dot of light in the image. A 0 would be totally black, and 255 is pure white, with every shade of gray falling somewhere in between. This grid of numbers, this is the only language the computer understands when it looks at an image. So our first step here is to really get a handle on these building blocks. How does a machine take a vibrant, colorful photograph and break it down into something it can actually process? Well, it all starts with the pixel. You can think of a pixel as kind of like the atom of a digital image. Every photo you've ever seen is just a huge collection of millions of these tiny dots, and each one has a specific number assigned to it that tells the computer how bright it should be. Now, for a simple black and white photo, it's pretty straightforward. One grid of numbers for brightness. But for a color photo, that's when things get really interesting. The computer actually uses 3 separate grids, all stacked on top of each other. One grid for red, one for green, and one for blue. By mixing the values from these 3 layers for every single pixel, it can create every color we see on a screen. Okay, so if an image is just a bunch of numbers, why can't we just feed that list of numbers into a standard AI and call it a day? Well, as it turns out, trying to do that leads us to a massive, massive challenge. Take a look at this number, 150,528. That is not a random number. That's how many individual numbers, or inputs, a computer has to deal with for just one small color photograph. Exactly. Just a standard 224 by 224 pixel image has over 150,000 values to analyze. If you just tried to feed that huge, long list of numbers into a traditional AI, it would be completely overwhelmed. It's a total recipe for disaster. And here are the 2 main reasons why it's such a bad idea. First, it's just too many numbers. The AI would get bogged down and would probably just memorize the training photos instead of actually learning what a cat looks like. But the second reason, and this one is the real deal breaker. If you just flatten the image into one long line of numbers, you lose all the spatial information. The AI wouldn't know which pixels are next to each other. It'd be like trying to read a sentence by looking at a jumbled pile of letters. All the meaning is lost. So how did engineers get around this? Well, they took a page from the best visual processor on the entire planet, our own brains. And this led to a completely new, revolutionary kind of AI. So let's meet the hero of our story, the Convolutional Neural Network, or CNN for short. Now, this isn't just any old AI, it's a specialist. Its entire structure is inspired by how our visual cortex works, by processing little overlapping regions of what we see to build up a complete picture. And the best way to think about a CNN is that it learns in layers, almost like a kid learning to draw. The very first layers learn to spot really simple things, basic lines, curves, maybe some color patches. The next layers take those simple lines and learn to combine them into more complex shapes, like an eye or an ear or a nose. And then finally, the top layers assemble all of those shapes to recognize the entire object, like a cat's face. So how does it actually do all this? Let's break down the step-by-step process of how a CNN turns that massive grid of numbers into a confident prediction like, that's a cat. It really all comes down to 3 core operations that repeat in a cycle, over and over again. First, something called convolution, which is where the network hunts for basic features. Second is pooling, where it simplifies everything it just found. And finally, classification, where it puts all the puzzle pieces together to make its final guess. Okay, so let's start with convolution. I want you to imagine a tiny digital magnifying glass, which we call a filter, and it slides across the entire image, section by section. This filter is designed to look for just one specific pattern, like a vertical edge or a patch of a certain color. As it slides, it creates a new grid called a feature map, which basically highlights everywhere it found that pattern. The network actually learns thousands of these filters all on its own. So, after finding all these features, the network has way too much information. It needs to simplify. And that's where pooling comes in. It takes those big feature maps and shrinks them down, keeping only the most important information. This does two really great things. It makes everything way faster, and it helps the AI recognize an object even if it's been moved a little bit or tilted in the photo. And here's a perfect example of the most common type, which is called max pooling. The AI looks at this 4x4 grid, but it does it in these little 2x2 sections. In each of those little squares, it finds the single highest number and keeps only that one. You see how the grid shrinks from 16 numbers down to just 4? It's a super clever way to keep the strongest signals while throwing out a bunch of noise. So after repeating this whole process, convolution and pooling over and over again, the network ends up with a collection of really high-level features. It's not seeing pixels anymore. It's seeing things like pointy ear shape or whisker texture. All these abstract concepts are then flattened into one final list and fed to a part of the AI that makes the final call. I am 95% confident this is a cat. Of course, what we just went through is the ideal process. But the real world is messy. Photos are rarely perfect, and that creates some really serious challenges for an AI trying to make sense of them. And engineers have come up with some incredibly clever tricks to handle these problems. For photos with bad lighting, the AI can digitally adjust the image to bring out hidden details. If an object is partially hidden behind something else, it can make a really good educated guess about the missing parts. To handle all the different angles and sizes an object might have, it learns to focus on key landmark features, like the corner of an eye or the tip of a nose, that stay pretty consistent. And for really cluttered backgrounds, it can essentially use digital scissors to cut the main object out before it even tries to identify it. So we've gone on this whole journey, all the way from raw pixels to a sophisticated, brain-inspired network that can navigate our messy visual world. But all of this, it kind of raises a much deeper, more philosophical question about what's really going on inside that machine. I think this quote just sums it all up so well. The AI isn't having some big aha moment. It's building its understanding piece by piece, layer by layer, starting from simple lines and ending up with a complete object. It's an incredibly powerful mathematical process, but it's a fundamentally different process from how we feel we understand the world. And that leaves us with this one final, really fascinating question to think about. If an AI can perfectly label thousands of different dog photos, no matter the breed, the angle, or the lighting, does it actually know what a dog is? Does it understand concepts like fuzziness or loyalty? Or has it just become an absolute master at recognizing the statistical patterns that we humans decided to label dog? That's really the question at the very heart of modern AI. Thanks for digging into this with me.